All right, and with complex numbers, the big thing, the big idea with complex numbers is basically this: that we're getting ready to solve equations, and we're working through different things and going through parts of it. And if you kind of think back, and somebody actually mentioned this the other day, that if we were solving x squared equals 16, and we did mention this a little bit the other day. What one thing we did say was that if you start with, if we're solving equations, if we're factoring and we're trying to solve, whatever your highest power of x is, that tells you how many answers you're looking for. So we're looking for two answers. And there's a couple different ways you can do this. You can either do this one like we kind of did before. If we were going to do the factor solve by factoring, we said we're going to basically set this thing equal to 0, so we could subtract 16 from both sides and have x squared minus 16 equals 0. That would be the difference of two perfect squares. So you can make that x plus 4 and x minus 4. And then you could set both of those numbers equal to 0, or both those parentheses. And solve those two. We get x equals 4. We get x equals negative 4. Okay, so that was one way you could do that, was solve by factoring. Now, I think last time when we were doing one of these problems, somebody said, well, couldn't we do the square root property? Absolutely. You could go back up here and you can take the square root of x squared and the square root of 16, and x would equal, and here's where you get your two answers, because if you take the square root of 16, it's some number squared, so you could square 4. So you could basically square root 16. Again, that could be 4 squared or it could be negative 4 squared. So that's where they would always say you go back and you put your plus or minus 4. Okay, so there's one where we could do that part of it and go from there. All right, so there's where we had the two answers. Now, here's kind of one thing. Here's where complex numbers comes in. What if that number that we're working with is a negative number? Okay, somebody said no solution, right? Because what happens if you try to take the square root of a negative number? All right, what number times itself will give you a negative number? Doesn't, right? If you do negative times negative, it makes it positive. If you check it on your calculator, if you do the second, do the square root of a negative 25, it will tell you, hey, that's a math error. Doesn't really work. So it's got to be a positive number for that to work. So that's basically, it's not real. It's not possible. So it's not a real answer. So here's the question, though. Here's what we do this one. Here's where complex numbers come in. They say this is not a real answer. Oh, yeah. It's imaginary. So it's like fake news. It's like it's a fake answer. But it's still an answer when you go through these. And it's one of those things that you talk a little bit about it in pre-cal. We talk about imaginary numbers and complex numbers. You would talk about it a lot. I think it's in Cal 3. If you go on and start taking calculus in college, there's a big chunk of it. I think in calculus 3. In between, there's not a whole lot with that. All right, so here's what we're going to do. Here's the big thing. This is what's imaginary numbers and the complex numbers. So when they talk about complex numbers, sometimes they talk about imaginary numbers. But here's the one great big giant thing that goes through with imaginary numbers. That the one big thing that they kind of key on is that I squared is going to equal negative 1. That's an I. Yeah, and when they show the I's in this case, yeah, the I in this case will always be italicized. You will not see an I. Well, I say not, but more than likely you won't see an I that looks like that. It's always going to be the I is going to be in italics. So they usually, now if you're using Math Excel, you can use just the regular I that's here. But most of the time in any book that you work through, they always show the I in italics. It's always got that curved eyelet to it. They hardly ever will you see it like this. It'll always look like that when you go through that part. All right. So did anybody do that? Anything with imaginary numbers in algebra 1? No? Maybe? Okay. A couple people said they did, depending on where you went through. Well, maybe if you had it one semester or the other. So, okay. All right, so here's the big thing with imaginary numbers. Okay, so imaginary numbers, they're going to use the variable I. And again, we're going to put in italics because that's usually the way it's going to look. Is it's always going to have that kind of curved, I to it. And the big thing with this one is that anytime you're working with square roots, and that's kind of where we're going with the next part of this one, is that anytime we're working with everything up to now, before when we took the square root of negative 25, we had no solution. Here's what we're going to do, basically, what it comes down to. Now we replace the negative with I squared. And that's for any time we're doing anything with the square root as you're going through these. Now, I thought you were, and back up here, you may have said, what about you said that the I squared equals negative 1. Here's kind of the way they kind of do that one so that you can kind of see what we're doing. So if we were solving this thing, we had x squared equals negative 25. That again, what we're going to go with square root property in this case. We're going to square root both sides. And what we're going to do is that when we square root those two sides, again, we know if we do square root of negative 25, we're not going to get a real number. It's going to give us the math error, and we're done with it. But what we're going to do is basically square root of x squared, we would get x. And when you square root the negative 25, and this, I'm going to give you the long process of it first, and then in a little bit, we're just going to say, all right, we're going to shortcut it and just go from here. But they've got negative 25. They actually replaced that with negative 1 times 25. That you just kind of pull the negative out separate from the 25. So really it's negative 1 times 25. And then this is where they're going to come back and use this part of the substitution that now we can take out the negative 1 and put I squared in its place. All right, but again, a lot of times we don't see it that way. We never put the variable first. We're always more comfortable seeing the variable second. So we're just going to rearrange it and rewrite it as 25 I squared. Okay, and if we were doing kind of like we're doing back up here, that if we were just doing x squared equals 25, we get square root both sides, and we would say that x would be plus or minus 5. So same thing here with this one. When we square root 25, that part's going to be plus or minus 5. And if you square root I squared, this is something we're actually kind of working up to that we'll get to eventually, but if you square root I squared, the square and the square root cancel each other out, and we'll leave you with just the I variable. Okay, so here's the shortcut. And then again, you don't have to go through this process every single time. That all you have to think about when we're doing these, when we're solving these equations, is if you have x squared equals a negative number, just take that negative number away. Think about being a positive number. Find out what that answer would be, and if it's negative, you just need to put I back in the answer. And that's it. That's all you're doing. So just think about if it was a positive number, what the answer would be. If it's a negative number, you just put the I in there to let you know, okay, this is not a real number answer because there is no number you can multiply by itself that will be a negative number. So they're saying it's an imaginary or it's a complex number when it comes off of that. All right, now, and here's one little tiny little thing that may pop up just for this one section that we're going through. But once we get past this first little bit of complex numbers, once we kind of move on past this the other days, we won't worry about this as much. I'm going to put this on the next page. Okay, so if the directions say to take the principal square root. Then just assume the answer is positive. Because sometimes when they're working through these, they're wanting you to work through the process enough, and they'll say, okay, don't worry about. So at that point, you don't have to worry about the plus or minus in that case. So if we were doing this problem and they said, give me just the principal square root, then at the end, instead of putting plus or minus 5i, then for this problem, if we had x squared equals negative 25, the principal square root answer would just be 5i. Okay, so sometimes they'll talk about just the principal square root, which means don't worry about the plus or minus. Just give me the positive answer. Just like a lot of times, if I say, what's the square root of 10? Or sorry, what's the square root of 100? Most people just say 10, right? How many people say 10 and negative 10? Not many, right? Yeah, maybe Charleston. Okay. But yeah, most of the time, if somebody says what's the square root of 100, most people just go 10. Most time people don't say 10 and negative 10. Yeah, occasionally you'll get somebody who's trying to be sharp and they'll say that. But most time you just give an answer, just so like this one. They'll say, all right, just don't worry about the positive and the negative. Just tell me what the answer is, and don't worry about the whole plus or minus thing on that. All right, now a lot of the stuff we're going to do for today is really work on this today, work on this some more tomorrow, work on it some more the next day. A lot of this is going to be going back to your 7th and 8th grade math for a little while, which maybe is kind of scary. Okay, so we got a little bit of review time. All right, does everybody remember how to simplify the square root of 72? I'm guessing they're probably not, right? Kind of, sort of remember? Okay. That is a 72, yes. All right. Yeah, that when you're breaking these down. Now, if this was square root of 81, we just put 9, we'd be done with it. But if it's not a perfect square root, you got to do a couple of different things. I'm going to show you some options that most of y'all probably remember. You remember doing the old factor trees? Then you would take 72 and you rewrite it as 9 times 8. And then you would take 9 and break it down as 3 times 3. And you would take 8 and write it as 2 times 4. And you would take 4 and rewrite it as 2 times 2. Y'all remember doing that? And then when you're simplifying square roots, you're always looking for your prime numbers. Okay, and just remember, your prime numbers that you're going to use for simplifying on these, it's the big 4, really it's the big 3, or 2, 3, and 5. Now, we could use 1, but 1's kind of, because again, 1's not really a prime number because 1 is itself, so we just take 1 and we say, all right, just don't worry about 1 because 1 is itself, it doesn't really fit the prime numbers. But 2, 3, and 5, that's your big 3 that you're going to break down. If you need the next one, 7 is there a little bit. But then after that, the other prime numbers show up, but they don't show up that much. That's your 11s, that's your 13s, that's your 17s, that's your 19s. That's the other numbers that are going to pop up. But you're going to get those numbers by doing, 2 times 17 to get 34, or you're going to do 3 times 13 to get 39, or you're going to have 5 times 11 where you get 55. So your big 4 really are 2, 3, 5, and 7. The other ones just kind of pop up a lot. And when you're trying to simplify these, basically you're taking these numbers and you're breaking it down until you get prime numbers. So we've got a 2 and a 2 and a 2 and a 3 and a 3. And then again, there's a couple of different ways you can do this. This is kind of the way I went with it. Is that you go back and write down all your prime numbers. You got 2 times 2 times 2 times 3 times 3. All right, so when we're simplifying square roots, we're going to go finding Nemo. We're going to find exit buddies. And your exit buddy has to be just like the other one. So in this case, if you've got 2 times 2, there's an exit buddy. So the 2 will get out. You got 3 times 3. That's a pair of 3s, right? So that 3 will get out. This 2 doesn't have an exit buddy, so he stays on the inside. Oh, it's so sad. All right, and then we've got 2 times 3 on the outside, so we can make that 6 square root of 2, and that's okay. So square root of 72 is just 6 square root of 2. And again, the only thing you have to realize different today is that if you have to do the square root of negative 72. All right, so it's square root of negative 72. The only difference between 72, your answer is 6 square root of 2. If it's negative 72 and you take square root of it, it's still 6 square root of 2. But in this case, the only difference is your answer is going to have the I in it. And where you put the I, it really doesn't matter. Sometimes they'll do it one of 2 different ways. They'll either put the I at the end of it so it's outside the square root, but sometimes they'll also do it this way to let you know for sure that the I is not inside the square root. So it could be one of either 2 ways here. They could either write it like this or they could write it like that. And I don't really care. The main thing is just don't have the I inside the square root. That's the big thing. And again, a lot of times they'll write it like this just so that you know that the I is not inside the square root. So a lot of things that we're going to work on is just basically, having you go back and work on some things and do some stuff with it. And it's just practice. It's going back to 7th, 8th grade math and breaking down your square roots to see what it is you can do with it. Now, let me show you this one. One other thing you can do on this part, and this is something I started teaching a little bit different than the old factor tree, because I remember sitting in y'all's position in Algebra 2, doing the factor tree, taking a number that was like, I remember having to break down like 720, some big number, and having my factor tree perfect, but missing this 2 that was way back up here in the beginning that was stuck. And I'd missed the problem just because I had a 2 that, even though I had on my paper, I just left it off because I didn't see it when I was going back and picking up my prime numbers. One thing you can do that makes things a little bit better, you don't have to do this. I'm just going to show it to you. This is the stack or the ladder method. So if you don't like the old factor tree method, if you do the stack or the ladder method, there's not, well, I'm saying not, there's not any way you can miss this problem. You won't miss numbers that you could possibly be hidden out in your factor tree. So let's say we had like 240. We had to take the square root of 240. Okay, so the big thing is with the stack or ladder method, go ahead and do this part like you're going to do, but do it like an upside down division. And when you divide, you can only put prime numbers that you're going to divide by. So this is dividing by prime numbers only. And I always tell people, start small. Start at 2. If it's even, you start at 2. If it's odd, you start at 3. And you just divide out as many of those numbers you can. So if it's 240, you can divide it by 2. Well, 240 divided by 2 is 120. Is that a prime number? No. You do it again. Still even. Divide it by 2. 120 divided by 2 is 60. Prime number? Nope. All right, so we'll keep going. All right, still even. We can divide it by 2. 60 divided by 2 is 30. Prime number? Nope. Just keep on going. Still even number divided by 2. 30 divided by 2 is 15. Is it a prime number? Nope. Is it even? No. So then we got to find some other prime number to divide it by. I'd say divide it by 3. 3 going to 15 5 times. Is that a prime number? There we go. Yes, it is. All right. So if that's a prime number, then you know that you stop. Yeah. Yeah. So if you get to the end, if that's a prime number, once you go down the list and this gets to be a prime number, you stop because that's as far as you can go. Here's all your numbers, and they're all stacked up nice and neat. And somebody call it the ladder method because it looks kind of like a ladder. If you look at the numbers here. So if you have to take 240 and break it down, instead of doing the old factor tree, you can just stack all the numbers up and think, all right, 240 then is 2 times 2 times 2 times 2. 1, 2, 3, 4. 1, 2, 3, 4, and then 3 and 5. And then you can do your exit buddies. That 2 gets out. That 2 gets out. That 3 doesn't have a buddy. That 5 doesn't have a buddy. So they stay on the inside. I know that's sad. 2 times 2 is 4. 3 times 5 is 15. And there's your answer to break down square root of 240. 4 squared of 15. Okay, so now you don't have to do it this way. It's just another option that if you want something that's a little bit cleaner, a little bit neater, a little bit more organized, because the factor tree, you just got stuff going everywhere. It's all over the place. You don't know where it is. This one, it's a little bit cleaner, neater method to help you find the numbers that you're looking for. Okay, and again, I don't really care which one you use. Just you get to pick, and you get to kind of figure out what you're doing. Again, the only difference between if this had been a negative 240. Well, if 240 is 4 squared of 15, this one is still 4 squared of 15. You either need the I at the end of it here, or you need the I there. And where you put the I, again, I don't really care. That may be one of those that you might, if it's Math Excel, you might want to click on the view an example just so you can see, because sometimes they're okay putting the I here and here. Sometimes they only want the I in one specific spot, and you might have to look at the example just to see where they want you to put it. So, but again, if we're doing a paper pencil test, I don't really care, because either way is correct. It's just some people like one way more than the other when it comes off of it. All right, so let me give you just a small one to practice here real quick. Let's say we're going to do the square root of negative 24. Okay, so again, if you think about 24, again, I'm going to go stack method. It's even, divided by 2, that's 12. That's even, divided by 2, that's 6. That's even, divided by 2, get you 3. 3 is a prime number, so if you break down 24, 2 times 2 times 2 times 3, you got one pair of exit buddies, so that 2 gets out. The 2 and the 3 don't, so that would be 2 squared of 6. Now, that's 24. So if it's negative 24, the answer is going to be 2i squared of 6, or 2 squared of 6i. So, all right, is everybody all right with that? Again, it's going to be some of the problems. It's going to take a little bit because it's just y'all didn't do it in geometry, so it's going to be going back and just remembering the square roots and how to go through those. We're going to practice on that some tomorrow, next couple of days, just to let y'all practice so that it goes a little bit quicker when it comes down to it. So, okay, and then the last little bit of time we got here, we're going to do a couple of things. We talked about complex numbers. Those are imaginary numbers. Here's what complex form is. It's not what you look like after you've done complex numbers for a couple of days. No, it's a different kind of form.
So the last part, how is it 2 squared root of 6?
All right, so when they talk about complex form, it's A plus BI, where A is the real number part. And then your imaginary part is the part of it that's second. So when they talk about complex form, you've got a real number, it's like 2, and you've got an imaginary number that's 3i or something like that. So now it's not a big deal, but a lot of times it's just one of those, they want it written a certain way, just like we'll talk about that sometimes you want something in standard form, that you start with the highest power of x and you work your way down. This is that same thing, that if your answer was negative 3i plus 12, technically that's a correct answer, but if they tell you to rewrite it in complex form, you just rearrange the terms and put the 12 first and the negative or the minus 3i second. Okay, is it a big deal? No, not really. But is that just the way they kind of want things written? Yeah, that's just the way they want things written. Just like when we just got finished with the quadratics test. If we had, most of the time you don't see the numbers written like this. That most time if your answer is like this, they'll tell you to turn back around and rewrite it in descending order so that you get this. Is that answer wrong? No, still the right answer. It's just not in the way they want it to look. So same thing here. This is not a wrong answer. They just like for it to have the real number first and the imaginary number second. Sometimes Math Excel will count you wrong for not doing it that way. Sometimes they let it slide. All right, so here's the big thing we're doing with this one. With complex numbers, we're going to do two things today. You're either going to add or subtract complex numbers. All right, and when you add or subtract complex numbers, this is actually pretty straightforward, really pretty easy. That you're going to treat the I variable like any other variable. So this is really going back to what we were reviewing back the first couple of days. That for this one, that all you're going to do is you're just going to combine like terms. And that's it. There's not, as far as addition and subtraction goes, there's nothing really unique. There's nothing really different about complex numbers than there is if we're doing X's or P's or Q's or, any other letter. It's all basically the same thing. So now the only thing that's a little different is sometimes when they rewrite or when they give you the problem, they'll give it to you like this. That you've got 3 plus 2i plus, and then parentheses -6 plus 5i. Because a lot of times people see that problem and they're like, well, do I really need the parentheses there? No, not really, but that's just the way they're going to write the problems when it comes off of it. So if it's there, again, you're just going to separate it out by like terms. You've got a 3 and a -6. So for that part, you're going to do 3 plus -6, or you can just do 3 minus 6 because of what's there. And then for the imaginary number part, you've got 2i plus 5i. So then we're going to do that part. All right, well, 3 plus -6 is -3. 2i plus 5i would be 7i. And there you go. And most people go, well, what's different about it? Nothing. As far as addition and subtraction goes, you don't do anything different with the I variable that you would do with any other variable that ever pops up when you go through those. The only thing you have to be careful of, and it's not hard, is just be careful with subtraction. And I think this was the same thing that popped up when we first started doing some review problems, that addition, everybody was good. Subtraction was the one that sometimes we would do a problem. People go, oh, yeah, I forgot to do that. Same thing with this one. So if we do 4 minus 5i minus 6 minus 9i, okay, first part of it, nothing you have to worry about. It's just 4 minus 5i. When you do the minus part, the next one, just remember that it's minus 6, but it's also minus negative 9i that you've got to basically think about. In that case, it's almost like a -1 that you're distributing out there. So it's -1 times 6 for -6. If you do a negative times a negative, that makes that a positive. Okay, and again, that was something I know that when we were reviewing back in the first week or so of class, that was that same thing. If we were combining like terms, that if you've got a minus in front, you've got to remember to change the sign of both numbers. So this was a +6, now it's a -6. It was a -9, now it's a +9. And then you can combine your like terms. Now you've got 4 minus 6, which would be -2. And then we've got -5i plus 9i, which would be plus 4i. Okay. All right, let me give you one more of those. Let you do a quick practice for that one, just to make sure okay. And then we'll do one multiplication problem or maybe two, and then that'll kind of wrap us up for the day. Straighten that up a little bit. Sorry, it's crooked. All right, so what I want you to do, go ahead and take just a few seconds and work this thing out, see what you get, and then we'll come back and just check it real quick to see if we've got the correct answer. All right, again, first parentheses, nothing to do different with it. Second parentheses, because of the negative here, change that to a positive 5 and a negative 4i. Again, technically, it's like taking negative 1 and multiplying it by both the numbers here. And then you've got negative 7 plus 5, which would be negative 2. And you've got the plus 3i minus the 4i. If you do 3i minus 4i, that's negative 1. And sometimes, again, this is kind of sometimes where Math Excel likes this answer, sometimes they don't. That's the correct answer. Again, it's just not necessarily in the correct form because a lot of times they don't put the 1 there. So a lot of times on the answer, they're going to put negative 2 minus I. Just like you wouldn't put negative 2 minus 1x. Same thing in this case. You don't have to put the 1 with the I variable. If you leave the 1 off, we're just assuming it's already there. All right, then the last thing for today, and this week we'll kind of do this, and then tomorrow we'll come back in and work on complex numbers just a little bit more. We're going to multiply complex numbers. All right, and with multiplication, it's either one of two things. It's either full method or it's distributed property. I would say 90%, 95% are going to be full method. So we'll show you one with distributed property, but then everything else we'll do full method because if you can do the full method, you can do distributed property because that's all distributed property is. Or full method is, it's just double distributed property. I mean, really what it comes down to it. You still do like we did before. You would treat I like any other variable. And here's the one difference. Unless you get I squared. All right. If you get I squared, replace the I squared with negative 1. All right, so let's say we'll give you 2 examples for sure. If we got time, we'll get in 3, but it just depends on how much time we have here. Okay, so we've got 6i times 2 minus 3i. Again, just distributed property. So it's 6i times 2, 6i times negative 3i. That's going to make that 12i. We do 6 times negative 3, that's negative 18. And again, the big thing you've got to remember is when you do I times I, that is going to be I squared. And again, that's just going back to combining like terms and all the basic stuff we did back then. That's the one thing you really have to remember with multiplication is that when you do I times I, you will always get I squared. All right, and when you get the I squared in this case, you're going to take out the I squared, replace it with negative 1. So we got 12i times negative 18 times negative 1. So if you do negative 18 times negative 1, that's just a positive 18. All right, and again, that answer is good, but it's not in what they would say the correct form. They would then tell you to turn back around and rewrite the answer in complex form. So final correct answer in the correct form would be 18 plus 12i. All right, now I know a lot of, because we just came out of doing factoring. Some people are like, do we need to factor that? No, no, no. This again, basically, we're doing full method distributed property, so everything in that case is reversed. That we start off with something in factored form, and you're rewriting it without the parentheses in the beginning. So in this case, don't go back and factor stuff out. I know it's maybe hard to do that because we just finished factoring, but in this case, you're doing full method and distributed property and combining like terms, so you don't have to do any factoring in this part. All right, everybody okay there? Again, if you can get the I squared and the -1 substitution, that's the whole big hinge where this thing kind of goes through this one. Let me give you one with distributed property, and I don't know if we'll get past this one or not, but we'll just see. So let's go with 2 minus 3i and then 4 plus I. Okay. And again, this is more kind of review because we haven't really sat down and talked about doing the full method. But if you've kind of forgotten what it was, basically it's just double distributed property. You're going to take 2, multiply it by the 4, and multiply it by the I. And if you forget about the I in this case, remember there's always understood 1 that's there that you could put. So we've got 2 times 4 for 8, 2 times 1i for 2i. And then we'll do distributed property with the -3i. So it's -3i times 4, which would be -12i. And then -3i times 1i. So -3 times 1 is -3. I times I will be I squared. And make sure you get that I squared because that's usually, if people miss this problem, it's usually when they do I times I, they'll forget to put the I squared. Most time, everybody else is good with all the other parts. It's just that's the one little thing that people will miss more often than anything else. All right, so the 8 is good. Nothing you can do there. You've got 2 minus 12i. That's -10i. Again, where you've got this I squared, replace it with -1. So that's -3 times -1. That's a +3. And so now you've got 8 plus 3, which is 11. And then you've got the -10i that would be there.